Hello, my dear learners. Well, in this particular module, we will briefly touch upon the various types of Autosar stacks. Okay, in the previous module, I explained to you what is meant by Autosar briefly, of course. As I said, Autosar is a huge topic, massive topic. It's not possible to cover the entire Autosar in this tutorial because if I go in depth, the entire tutorial will become Autosar itself. Okay, so and within Autosar, there is one more topic called Autosar stacks. Okay, what are these stacks? What are their responsibilities in ADAS? How do they what are the major roles played by the Autosar stacks in ADAS? We will briefly touch upon. Now, Autosar software architecture overview. Autosar follows a layered architecture where each layer has specific responsibility, and the major layers in Autosar are application layer, runtime environment, basic software. And again, within basic software, there are three layers: services layer, ECU abstraction layer, and microcontroller abstraction layer. Now, as I said in the previous video, if you want to learn about Autosar very extensively, I strongly recommend the video. In Udemy, there is one guy called Sham, but I think I already mentioned it, but nevertheless, here also I mention Sham. But this guy's tutorial about Autosar is available in Udemy, and this particular tutorial is a very good tutorial. Okay, you will learn extensively about Autosar. All right. Now, when it comes to complex device drivers, this is also one of the important vertical of the Autosar, and the stacks in the Autosar refer to different functional clusters within basic software that provide specific services. These stacks are grouped based on their functionalities. As you can see in the below illustrations, below pictures which I have pasted on the bottom of the slide, you can clearly see where exactly the complex device drivers are placed. Here the complex drivers are placed, and again here also complex drivers are placed. Okay, so to continue further, what are the major stacks in the Autosar BSW? The basic Autosar BSW is divided into several stacks, each serving a different purpose. In this picture, you can see that within every stack there are further more subsystems. Okay, so with this system will give you a very comprehensive idea about how complicated this Autosar is. All right, but let's try to touch upon some of the basic subsystems which are important in ADAS perspective. Now, first one is system services stack. This stack provides fundamental services required by ECU and other software components. When it comes to operating system, the real-time operating system compliant with Autosar operating system specifications, which manages the task, interrupts, scheduling and resource management. Now, in case you find this very intimidating or big bouncer over your head, just ignore it. As of now, you just note down in notebook, and when you learn about Autosar extensively, all this will make sense. Okay, as of now, you please understand the minute role played by each and every stack, this vertical in Autosar. When it comes to error manager, it detects and reports runtime errors. It logs errors for debugging. And coming to watchdog manager, monitors application and BSW for correct execution. And it also triggers recovery actions if a fault is detected. Now, coming to ECU state manager, which is acronymed as ECUM, it manages the ECU startup, shutdown and sleep modes. Okay, every electronic control unit has various types of modes: startup, shutdown and sleep modes, and this manager, it manages all these various types of modes. And next, coordinates with BSW modules during the state transitions. When it comes to communication stack management, controls communication modes: full, silent and also no communication, and it manages network wake up and sleep. Now, coming to the another stack called diagnostic event manager, It handles the diagnostic events, which includes the diagnostic trouble codes, and it is the actual event manager which displays the various kind of diagnostic errors onto the display panel. And diagnostic event manager, it interfaces with diagnostics, and the function inhibition manager, it enables, disables software functions based on conditions. All right. So, these are all the major types of stacks in Autosar BSW. BSW stands for the basic software. Now, when it comes to memory services stack, remember that memory services stack manages non-volatile memory operations. And within this non-volatile memory operations, the NVRAM manager provides an interface to store and retrieve data in non-volatile memory. It handles block management, checksums and redundancy. These are all very, how to say, fundamental electronic terms. So, in case you don't understand, please just note them down. And if you do a very short term search in Google, you will clearly understand the efficacy or the importance of all these words. This block management, checksums, redundancies in NVRAM why NVRAM manager plays an important role in handling these things. Okay. When it comes to flash EEPROM emulation, it emulates EEPROM using flash memory. It also manages where leveling and block allocation. Okay. EEPROM abstraction, when it comes to EEPROM abstraction, it provides direct access to EEPROM memory if available. And when it comes to flash driver, low level driver for flash memory operations like read, write, erase or handled by flash driver. So, these are the various subsections or sub parts of the subsets of the memory services stack. Now, when it comes to communication services stack, there are 8 major parts. Okay, from 1 to 8, we will clearly touch upon one after the other. First is the communication stack, provides basic communication like signal gateway and IPDUs. It also interfaces with RTE and PDU router. In PDU, when it comes to PDU router, it routes protocol data units. Now, this is what PDU stands for, protocol data units between communication modules. And it also supports CAN, LIN and FlexRay Ethernet. Now, in case you are coming from mechanical background, you don't understand these things, you please understand that this whole thing is a subset of communication. The data coming from sensor to ECU, ECU to actuator, or this whole communication services stack, it plays a very pivotal role in data communication. And when it comes to CAN interface, abstraction layer for CAN communication, routes CAN frames between upper layers and CAN drivers. And when it comes to LIN interface, abstraction layer for LIN communication. Next comes the FlexRay interface. I am sure everybody is able to recollect that CAN, LIN, FlexRay, Ethernet or the various types of protocols. FlexRay interface, abstraction layer for FlexRay communication, Ethernet interface, abstraction layer for Ethernet communication. And when it comes to transport protocols, handles large data transmissions, diagnostics over CAN or Ethernet. Diagnostic communication manager manages diagnostic requests like UDS, OBD2 and also interfaces with DEM. DEM stands for diagnostic diagnostic erasable memory and communication stack. Now, other interfaces are hardware abstraction stack, provides hardware independent access to sensors and actuators. Hardware abstraction abstracts ECU specific IO signals and maps hardware signal to software. What is the meaning of abstraction? Abstraction is nothing but it ensures that signal does not go beyond that layer. It does not go to further lower layers. That is the meaning of abstraction. In a very crude language, abstraction means blocking or ensuring it does not go beyond. Now, when it comes to ADC driver, it reads analog signals, and when it comes to DIO driver, it controls digital input output pins, and when it comes to PWM driver, it generates pulse width modulation signals, and ICU driver input capture unit measures pulse width and frequency. Now, all these are subsystems of hardware abstraction stack. Now, when it comes to crypto stack, the crypto stack provides security and cryptographic functions. And what are they? First is the crypto service manager, which manages the cryptographic operations, which include encryption, decryption, and hashing. And when it comes to interfaces with crypto drivers, crypto driver implements cryptographic algorithms, okay, which are acronymed as AES, SHA, and RSA. And coming to secure onboard communication, SECOC, it ensures secure communication or message authentication. Now, last but not the least comes the ECU abstraction layer, and ECU abstraction layer provides ECU specific hardware abstraction, and ECU configuration manager handles the ECU configurations and initialization. And ECU abstraction modules CAN-SIM, LIN-SIM, and FR-SIM, they manage state machines for communication buses. Okay, and when it comes to complex device drivers, which is also one of the layers of the Autosar, it is used for non-standard hardware or performance critical functions. It also bypasses layer for any direct hardware access. Okay, so whenever from RTOS to the bottommost layer hardware, it can bypass all the Autosar layers for direct hardware access. Now, just to summarize the various Autosar stacks, the system service is there, memory service is there, communication services, IO hardware, crypto security, and ECU abstractions. And in the table you can clearly see what are the key modules of these various stacks. So, in conclusion, the Autosar stack based architecture ensures modularity, reusability, and standardization across automotive ECUs. Each stack provides well defined functionalities enabling seamless integration between software components from different suppliers. The layered approach also simplifies development, debugging, and maintenance of automotive software systems. Okay, I hope all of you got a brief idea. At least you understood by heart the names of the various stacks that are provided in the Autosar when it comes to ADAS. Not only ADAS, for the entire vehicle, these are the various important stacks. In the next video, we will briefly touch upon the ADAS stacks strictly in the ADAS context.